Okay, we're recording. So good evening, everybody. So this is College Algebra here. We're going to talk about circles today. And I'm kind of looking at your homework here. And we're just going to kind of go through and see what they have here. So this problem here is all they're asking us to do on this is just to verify it. Okay. So what we're going to do is we're just going to check to see if I put these points in, does it make this statement true? That's all you have to do with this, okay? But I also understand that it's it's probably a weird thing to ask somebody to do. So we have the point, right? -12, -15. This is always your x, this is always your y, okay? The first one's always x, the second one's always y. And what we're gonna do is we're just gonna type this in. We're gonna say, well, this is -12 plus 18 squared plus, and then we'll go ahead and say -15 plus 23 squared. And I'm going to put a little question mark on top of the equals because I don't know yet. Is that equal to 100? Okay. So what we're going to we're just going to go through this order of operations, right? -12 plus 18, that's going to be 6 squared plus, and then -15 plus 23, what's that going to give me? It's going to give me, that's going to give me 5. That's going to give me 8, isn't it? Okay. And again, I don't know if it's equal to 100 yet, but we'll find out. And then the next thing we get to do, right, order of operations again is there's a squared up here. So we're just going to say that's 36, right? 6 times 6. That should be a plus. And then 8 times 8 is 64. And is that equal to 100? And it sure is, right? 36 plus 64 does 100. Check. That's it's all set. That is a point on the circle. So if they say, is this a point on the circle? Yes, because this, if I plug these points into x's and y's, we're going to get something that's true. So we're going to know that that's the way that works. All right. So I'll skip around a little bit. Like this one, I don't know if we need to do this one. So I'll skip around a little bit. Okay. Determine the center. So this one we'll talk a little about what circles are and what radiuses are and everything else. Okay, so your form of a circle, right, is x minus h squared plus y minus k squared is equal to r squared. Okay, this is your form of a circle. Notice both variables have a squared on them, and h's could be 0. That's okay. K could be 0. That's okay. So if you see an equation, right, that looks like x squared plus y squared is equal to 36. That's a circle, even though there's nothing here. Okay, 1 second. I gotta hit my T here because I don't want that going off more in the middle of doing all of this. Nice chilly day, almost snowing in New Mexico, so we're having some tea here. All right, so this H business here, this stands for horizontal. K is, if you look up the Greek word for vertical, it'll start with a kappa, it'll start with a K. So this is the offset horizontal, this is the offset vertical, and that's what tells you where the center is, okay? And this negative sign, that's the tricky one. This belongs to the equation. So if I see x minus 1 squared plus y minus 2 squared equals, say, 100, okay? These are not always a perfect square. It's just that if you're dealing out of a textbook that wants to make things nice for you, they generally are, okay? But they don't have to be a perfect square number. They could be an irrational number. It could be like 7, and then it's on you to figure out where the square root of 7 is when you're drawing your circle. But in this case, right, the horizontal offset is 1, right? H is equal to 1 because the negative sign belongs to that formula. The negative sign belongs to the formula, so the K is equal to 2. So my center, I think I could spell. Okay, the center is going to be, going to be 1, 2. It's the h and the k. Right? Now, they can be a little tricky because what if we do something like x plus 1 squared and y plus 2 squared equals 100, right? So in this case, it's a little bit trickier because the negative has to belong to that, belongs to the formula here. So we have x, and I need to turn this positive. I need to get a negative in here somehow. And what we're going to do is we're going to minus a 1. And that'll turn this thing into a positive, right? That if I do x minus minus 1, that's really the same as x plus 1. Same thing, y minus a minus 2 squared equals 100. So my center now, right, because x minus what? X minus my negative 1, y minus k. So we have a negative 1, negative 2. All right, so be careful about that. That's kind of tricky. And then over here, right, we have r squared, and this is another one. It's easy to mess this one up. You know, r squared is equal to 100, so r is equal to the square root of that. We got to go with 10. All right, so that's what these letters mean in your circle equation. Is your offset for your horizontal, your offset for your vertical, and then your radius squared. Okay. So when they go back over here and they say, well, we have this one, what am I going to do? Well, notice both of the negatives are still here, right? So I don't have to worry about trying to figure out what the signs are because x minus what h is, so that's just going to give me 7. And y minus what k is, and that's just going to give me 5. Okay, they do let me do it. So my radius squared, right? The radius squared is equal to 49. So in this case, we have r squared is equal to 49. So r is equal to the square root of that, or 7. Okay, so r is equal to 7. And it's okay that part of the center is that they're not, you know, they don't have anything to do with each other. So if the numbers are the same, that's fine. It's a coincidence. If they're not the same, that's fine. It's a coincidence. All right, and we can go through and check to make sure that that's going to work for us. They don't always. I'm not. You know, when you guys complain about, you know, that it's hard to type things in because they don't really take you know, the format you gave it in. I feel your pain. I really do. I have the same problems you do. Okay. So in this case, right, we have x squared plus y squared is equal to 12, right? And here, right, we could rewrite this as x minus 0 squared plus y minus 0 squared. So if you're having a little bit of trouble trying to fit something like this into the form you just learned, you can always put a 0 in like this. Okay, so my center here is just going to be 0, 0. Now my r squared is equal to 12. And they do not, okay, this is not the answer. They do not want you to go through and do this and say, oh, what's the square root? No, I don't want that. I want the square root of 12. They do not want you to write this down. The answer is not, okay, 3.4641 dot, 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 dot. Okay, they'll get mad at you if you do that. Okay, this is probably a good one to do it because the centers are just 0 and 0. Okay. Oh, how come you, it's not a good one to do this with because I got to do it twice now and they blocked the page from me. Okay, what did we say? 3.4641. Is that what we got? 3.4641. 3.464. See, they're gonna they better get mad at me. See, they don't like that. So they want the exact value. They don't want the calculator value. So don't do that. That's they're yelling at you for that. They are also not going to want square root of 12. Okay, that's not going to be the right answer either because it's not simplified. All right, so what we're going to do is we're going to fish inside of 12 and see if we can find anything that we can say 12, you know, something times something, right? A times B, that'll equal 12. And we want one of these numbers to be a perfect square, right? So 1 times 12, that ain't going to do it. And 6 times 2, that ain't going to do it because both of those don't have squares. But 4 times 3 is equal to 12, right? So really what we're going to do here is say, well, 12 is equal to 4 times 3, and that's going to be the square root of 4 times the square root of 3. What's the square root of 4? Is 2. Okay, now we can't do anything with the square root of 3, so it's okay to set this up and leave it as is. But that's the answer that they want here, is to say this is 2 root 3. All right, so this is 2 square root of 3, and that's what they're looking at. All right. Last year I taught the statistics version of this course, and the people that would log on in the morning with me to do this, they had mornings, you guys have afternoons, it's fine. But she would sit there and pretty much follow along, doing her homework exactly as I was doing it too, and it worked out real well for her. So you know, if you're sitting here like, oh, I could be doing something else, like I guarantee you, you know, typing this in as I'm doing it is a good way to go. And you guys will be less shy over the course of the semester, because she'd stop me. She's like, wait a minute, mine looks like this instead. Is that okay? Like, yeah, let's look at that problem. So she'd read it off to me and we do that one as well. Okay, so if you're sitting here wondering, like, I can't sit here and listen to him, like, I get it. That's okay. Do your homework. It's fine. I'm not going to see you. I'm not going to know. Even if I did, students have done that to me before. It's like, I can't really listen to you. Can I just sit in the back and do my homework? Like, that'd be fine. You said it more politely than that, but still. Okay, determine the center and the radius. And like, this one is a little bit harder, right? Because they give us fractions, and that's always a little scary. But in this case, right, not too bad, right? We have a minus thing going on here, right? That's x minus a negative 4/3, right? Remember? And then here we don't have to worry about it. We already have the minus. And I'm not going to do anything with this yet either. Okay. So my center here is negative 4/3, okay, and positive 1/6. Right? I'm glad they didn't ask me to graph this, because this is going to be a pain. But all we have to do is point it out. Now, my r squared, right, is equal to 81/4. So my r is equal to the square root of that. And just like with the 12, we are allowed to take this apart and say, well, this is r is equal to the square root of 81 over the square root of 4. And that's a legal thing. You're allowed to do this. Now, if there was a plus in here or a minus, then we can't do it. But if we have a fraction or times, then you're allowed. Okay. Square root of 81 is 9, square root of 4 is 2. And that's going to be what our center is. All right, so our center here, what do we have here? We have negative 4/3 and a 1/6. So negative 4/3. And then here we have 1/6. Okay, I'm just typing it in with the keyboard. Okay, and they make me do this. Okay. And our radius, that was 9/2, wasn't it? Or 2 of 2. All right, there we go. All right, let's see. Let me double check. 7, what did 7 ask us to do? Yeah, we could do that. It's you guys are pros. We could do that. Oh, this is a graphing one, so this is gonna be trickier. All right, so the first thing we have to do is we have to write the equation of the circle in standard form, and then we have to go graph it. Okay, so here they told us the center, right, was at 0, 0. The center is at the origin, so you don't need to write the 0 to do this. I mean, you can, but you don't need to. So we could just say this is x squared plus y squared equals an r squared. And again, this is a thing where it's going to be a little bit on the tricky side. Now, since they gave it to us as a decimal, I'm going to assume that they probably will be okay with you giving them back a decimal. But I'm going to be safe. I'm going to say, well, that's 7/2, right? 3.5 is 7/2, and that's equal to 49/4. Okay, so they probably want that. We could always check though, right? We could always say, I don't know what 3.5 squared is off. I mean, I know it's 49/4, but okay, 12.25. Let's try it and see if they'll give us 12.25. Okay, generally, my rule of thumb is that if you have a decimal that ends in a 0.5 or 0.1 and you leave it as a decimal, then I don't have a problem with it. if you converted 1/7 into a decimal and then didn't convert it back, then I'm going to have a problem. All right, but let's go ahead and see that. So we have x squared, okay, plus y squared. I'm just using Shift 6 to do that as well, okay, and it equals, and let's see if it lets us get away with 12.25. Okay, they don't give us any sort of anything else on here. All right, so let's, okay, I guess we're gonna have to take it. See, this one, I wanted them to say check it every time I did something. And now we don't have that. Okay. So how am I supposed to generate points to see if this is actually gonna work? Okay, how am I gonna do that? So, and how am I gonna type them in? Because they're, you know, I got this thing. So one thing we can do, right, is we could say that x is equal to 3.5 and y is equal to 0. We could say that x is equal to negative 3.5 and y is equal to 0. If I plug these back in, right, we get 3.5 squared, 0, is equal to 3.5 squared. I'm like, okay, I'm happy with that. And if I plug in the negative one, right, by the time we get around to the negative part and square it, that negative is going to disappear. So be careful with that too, because calculators lie to you sometimes. Okay, if you square a negative number, right, positive or negative, and you're squaring a negative number, it better be positive. So even if you type this in, see, watch, I'll do it. I'll show you. They'll say negative 3.5 squared, and it's going to give me a negative number. So what it thinks is you went this. So order of operations, it does the squared thing first, and then it treats that as a multiplication, and that's how you got a negative. But if you type it in this way, then it does the inside the parentheses stuff first, and you have a negative. So parentheses, oops, I didn't put a parentheses, parentheses, negative 3.5 squared, right? Now it's going to give me a positive number, okay? So if you're in doubt and you've typed in something with the calculator, realize that that's probably the mistake you made, because it's a very common thing for students to forget. And some people are very blind to the calculator, like the calculator says it, I will obey. And that's not how that's supposed to work. You're supposed to engage your own mind. And speaking of engaging your mind, and come up with I mean, the calculator is supposed to help you. It's not supposed to do the work for you. Okay. So in this case, 3.5, x equals 0, and then y equals negative 3.5. So all I did here, okay, so I'll draw it out first. So that's my reasoning, is that here's my center, okay, and we have to go 3.5 in every direction. This direction would be hard. I don't know how to figure out like what a good thing to do here, okay? So I would not want to try to generate numbers that was this point or this point. But this point I'm pretty good at. This point I'm pretty good at. This point I'm pretty good at. And this bottom point I'm pretty good at. So these are the first four numbers I'm going to pick when I've got to generate a circle. I'm just going to go from the center directly up, center directly down, center to the left, center to the right. Okay. And then we'll see whether or not they're going to take our thing here. So graph the circle. Did they tell us how many points we needed? No, they didn't. All right. Well, here's the other thing. We could try to use the pencil. And if you're trying to do this at home, you're going to see like I can pick 3 or I can pick 4, and that kind of doesn't work. So what we're going to do here is we're going to pick this little graphing window here. And what that's going to let us do is type in numbers that we need, okay? Generally, if you want to type in something like the square root of 7, you can just type in the square root of 7, all right? Don't try to do coordinates for it. It says right 1/3, not 0.33. So what we're going to do here is we're going to have 3.5, oops, I wanted 3.5, 3.5, and then 0, all right? Really? We'll say plot point. Notice they gave us a little point here. Okay, we have negative 3.5 and 0. Plot my point. And notice we got a little x here. Same thing is going to happen over here. We do 0 and then 3.5. All right, plotted that one. And 0 and negative 3.5. And it'll put me a problem down there. Okay. So I know it puts it in there before you say plot point, but if you don't see plot point, then it doesn't clear right, and it gets kind of weird. And then we're just going to go ahead and here's the center, and we're going to place a point on the circle. And notice it went through all 4 of them. Of course it did. And then that's how we're going to go ahead and graph these things. So that tool is a little bit, it's not intuitive. It's not the easiest thing to learn to use the first time you see it. But we're going to go. How is the negative 3.4 negative? Hold on for a second here. Oh, that was the previous one. I'm sorry. I missed your question earlier. Let's go back a little bit. Okay, that's what this one is, right? The negative 4/3 being negative. So the reason why that has to happen is because this formula demands that this is the format. Okay, so it demands that there's a negative sign in the middle here. Both of these demand that there's a negative sign. So how do we make the negative sign? And we turn this positive into 2 negatives, and that's why this ends up having a negative attached to it. Okay, this one we didn't have to worry about. It came with a negative sign, like good, it came with a negative. But since this one didn't, we have to break this positive number, positive sign, into 2 negative signs in order to do that. And then this guy gets the negative part of it. Okay, so it's part of it. It comes with the formula. It must be part of that. Negative sign has to be there. Otherwise, it's not the right formula. It's not the right form. Okay, so anytime you see a plus in here, realize they're trying to mess with you, and you gotta take the opposite way around. Okay, so I'll try to be better about looking at my chat here to do that, and we'll see how we do. All right. So yeah, let's see what else we have here. Oh, my favorite problem. Okay, the endpoints of a diameter are these 2 pieces here. Write the equation in standard form. Okay, I guarantee you that, and this is a nice one. Okay, it's pretty tame, but there's a couple of moving parts to this, so you have to be kind of careful with it. Okay, so let's go ahead and graph it first and see what we have, and then we can get started with actually solving it. All right, so we have the diameter of a circle, and we have 1, 2, 3, 4, 5, 6, and a negative 1. So we've got a point here. And then on the other side of this, it's negative 2, negative 7. Okay, so negative 2, 1, 2, 3, oh, negative 7, 1, 2, 3, 4, 5, 6, 7 down here. Okay, so forgive me this circle because it is going to be terrible. Okay, so pretend this is round. Okay, but that's kind of my circle, okay? And what they're trying to do is we need to, right, we want to know, pretend it's also in the middle, okay? They want to know like where the center is. That would be here, right? For X marks the spot, but I can't just estimate that, okay? I mean, that's like kind of negative 4-ish, maybe negative 2-ish or 2-ish. So maybe negative 4, 2. And whoever this long is, like, I don't know what's this length? Right, that would be my diameter. All right, so we have to do 2 things. We have to kind of figure out how do I get the middle of these 2 points? And then how do I tell how long it is? And you should say at this point, wait a minute, I've seen that before, like recently, yesterday when I was doing my homework. Right, so that is the midpoint, right? And remember, the midpoint is just the average of the ordinates. Okay, it's x1 plus x2 divided by 2. Okay, y1 plus y2 divided by 2. Right? I live in one of the older New Mexico houses, so you're going to hear my heater come on in the wintertime, especially today, because it's going to get nasty for weather. But we'll see less of that as we get more spring. Okay. So yeah, we're just going to average these things. So we need the average of 6 and negative 2. Okay. So we have 6 plus negative 2 divided by 2. And then for the y's, we need negative 1 and 7. All right. So we're $6 and we pick up a $2 IOU. So 6 minus 2, that's going to be 4 over 2 here. If you're $1 in debt and then spend another $7, now you're $8 in debt. Okay. And I do the money thing because people are really good at counting change and really good at counting money and not so good at abstract numbers. So I'm not doing that to treat you like your children. I'm just doing that to make it easier for people to facilitate, like, how do I add this thing quickly, right? So you don't have to use a calculator for all of it. You can get some of this. Okay, and be careful if you do use a calculator, all right? If you just type it in as you see this, you're going to get the wrong answer. We know the answer is 2 and negative 4. But if I type in this, if I say 6 minus 2 divided by 2, the order of operations is going to get me because it's going to say, oh, we need to do the division first and make that a 1. And then 6 minus 1 is going to be 5. That is not the midpoint. All right? So what you want to do is you want to say parentheses 6 minus 2 parentheses divided by 2. All right? That's what you want to do. So be careful about that. I see a lot of students that's a big problem for them. But use those parentheses and make sure you can do it right. And you don't really need the parentheses. You could do this. Okay. So what's this ordinate down here, right? This was negative 2, negative 7. And this guy here, this was 6, negative 1, right? So if I just make a little triangle here, I'm going to give them addresses, right? This is negative 2, negative 7 here. That's this point. And this point here, I'm going to give 6, negative 1. We want to get this hypotenuse. So the first order of business here is like, well, how long are the sides of the triangle, right? How long is this side? How long is this side? Okay. So what we're going to do is we're going to say, well, wait, this was positive. It was positive 6. So we have 6 here and 7, 8, right? 6 and then 2 more. So this point here is 6 minus a negative. 6 minus, right, a negative 2, which is 8. So I know this length here, this x length, is 8. All right. So we're going from 6 all the way down to negative 2, or negative 2 all the way up to 6. So that length is 8. Lengths are always going to be positive. All right. That's the thing about lengths. And then for the y parts, right, we have a negative 1 here and a negative 7. Well, how do I get that length? So that's going to be negative 1 minus a negative 7. Negative 1 plus 6 is equal to, negative 1 plus 7, rather, is equal to 6. Okay? So this length up here, this is 6. Okay? And if you do it carefully enough, maybe if you do it on graph paper, I mean, you could actually count this out, and that's okay. So I've got a side of 8, a side of 6, and we have to figure out the hypotenuse, right? And that's going to be, right, a squared plus b squared is equal to c squared. That's something we've done. All right, so a squared, okay, I always make a though, so I don't know, along the side here, along the bottom. Right, that's 8 squared plus 6 squared is equal to c squared. So it's 64 plus 36. I think we've done this one, right? So that's 100. That's equal to c squared. So c is equal to 10. Right? That's the diameter. So this is the, we'll say it this way. This is the diameter. So the last thing is left to do is, well, that's the diameter. What's the radius? Right, that radius is going to be half of the diameter. The radius is 5. When I want to turn this thing into standard form, we have to say, well, r is equal to 5, so r squared must be 25. All right. So with all of that, okay, I'm sorry that my favorite problem is kind of a long one, but usually in a face-to-face class, I have the opportunity to just break it down into sections and say section A, like, what's the center, section B, what's the radius, and then section C is put it all together for me. I don't know how I'm going to do that with Connect, but there we go. Okay, so standard form. I've got to go back to my thing here. Here's my center, right? Is 2, -4. So my center is 2, -4. So we're going to say this is x minus 2 squared plus y minus -4 squared is equal to 5 squared. So this doesn't need to be cleaned up, but this one does. They're going to get mad. If you say negative, they are going to get mad at you. So you really got to change that over to y plus 4. And again, they're not going to want 5 squared. They're going to see 25. Okay, so that's my equation of my circle. Right, so let's see about putting it in here. And we're going to have the equation is, I wonder what they want. Oh, I think they just want any circle for this first one. I think they just want an equation of a circle in standard form. I think they just want this. So let's see. No, they didn't like that. Okay, well. Oh, equation of the circle. All right, there we go. Good for me for reading pronouns, right? So we have x plus, okay, x minus 2 rather. X minus 2. Squared plus, oops, not that plus. I have to press the forward arrow to get out of that. Okay. All right, I think that's our circle that we're looking for, right? X minus 2, x plus 4 is 25. Good, very good. So let's recheck this thing. All right, that's much better. Oh, part 2 is to graph it. Okay, so here, all right, again, let me draw this thing out and we'll talk about how to graph this thing. So we've got a circle that looks like this. Actually, I'm going to cheat a little bit and we're going to do it this way. So we've got 1, 2, right? And then a negative 1, 2, 3, 4. So one way that I like to do my circles here is that the radius is 5, right? The radius is 5. So I know that the circle is 5 from every direction in the center. Okay, so if I do 1, 2, 3, 4, 5, I know that's a point on my circle. Right? 1, 2, 3, 4, 5, that's a point on my circle. That's a point, and then 1, 2, 3, 4, 5. So what I know is, like, what is this point down here, right? This was 2, -4, right? This was 2, -4. So if I just march myself directly north, right, 5 points, what's that going to look like? Well, that x doesn't change because we're marching directly north. -4 plus 5 is 1. Okay. If I march directly east, right, I'm going to go 5 more points in the x direction. So that's going to be 2 plus 5. That's going to be 7, right? That's 2 plus 5. And then we didn't change our altitude, right? We didn't change north or south. We're still at -4. Okay. And then going down here, right, we're just going directly south. So we're still at the same x value, right? But the north and south value is changing. Since from -4, -5, 6, 7, 8, 9. Right? -4 minus 5 is -9. Okay. And over here, right, we're at 2, and we're going to say 2 minus 5, right? That's going to be -3, right? 1, 2, 3, 4, 5, we're at -3, and we're not changing, right? We're not changing north or south, so that's how that's going to go. Okay. In this case, they tipped us off. They gave us 2 extra points before we even started because they said 2 of the endpoints on the circle are these guys right here. All right. So we can go ahead and type in 6, -1 and -2, -7 because they gave it to us. Okay. So in this case, again, they gave us the pencil. Hooray. All right, and then we can be able to go ahead and do that. So we're going to say 6, -1. 6, -1. 2, 4, 5, 6. Oh, did they let us go halfway down? It looks like they do. All right. And then we have what? -2, -7. No, that's not right. Or is it? -2, -7. We're okay. So -2 and then -7. All right. And I'm going to go ahead and erase that one because that was a stray mark. I didn't need to click that. All right. So we are at 6, -1 and -2, -7. Well, what if you don't like that? Okay, what if you would have rather typed it in and not have to worry about trying to be good with a pencil? Okay, so how about -3, -4? How about we put that one in? All right, so that's going to be -3, -4, and we'll plot that 4, and we'll plot that point. All right. And what other one do we want to do here? How about 7, -4? 7, -4. There we go. All right, and let's see if we can't pick the circle. What is our point here is our middle rather is 2, -4. So let's see if we can't force that. So let's go with 1, 2, 1, 2, 3, 4. So that's our center, right? And then we're going to go here. And again, notice all the points line up. I guess you didn't really need to check all of those points because it did a lot of this for us. But you know, it's still nice if maybe they didn't give you a specific tool or they wanted you to do more of that, so you don't really have a good idea for that. All right, but it's a good idea, like to get practice using this thing because we're going to be graphing more difficult things as time goes on. All right, so let's see. So this one, I don't know if we need to do this. Let me go back and hop around a little bit. We might come back to that one. And that's, oh, these are going to be good. All right. We need to make sure we're getting the right one. All right. Yeah. All right. This is another problem that I really like is this kind of a problem. So it gave it to us it didn't give it to us in standard form. It's still a circle, right? Because we have an x squared and a y squared. So it's probably a circle, all right? But, that doesn't tell us what the middle is, all right? So what we're going to do here is something called complete the square. Right, this is a really useful technique, especially if you're going to go on and you're going to take pre-calculus. You're going to need to know how to do complete the square. And if you're going to go on and take engineering calculus, you're going to have to be able to complete the square. Okay. If you're not going on to those things, I don't know if you use it in the algebra physics or not. You might, okay, because it's very useful for figuring out circles and ellipses and things like that, and orbits or ellipses. So we might have to do this for physics as well. Okay. So what we're going to do here, right? We have x squared plus y squared plus 8x plus 4y minus 5 is equal to 0. Okay. Now, I want to warn you, or I want to tell you that there's several different methods for doing this. They're all the same, but they're going to look a little different. All right. So if you had a high school teacher show you how to do this, and mine is a little bit different, but you loved how your high school teacher did it, then you just keep doing it that way. Or if you have a tutor and they say, well, that's an interesting way to do it. I never would have thought about that. That guy's crazy. And here's a different way to do it. Then pick the one that works for you. All right. So they're all equivalent methods. It's just that the terminology that they use or how they set this up can be a little different. So just because mine may not look the way that your favorite way did, doesn't mean that you're wrong. It doesn't mean that I'm wrong either. Okay, it's just a slight way of wrapping this up. So the first thing I'm going to do is I'm going to generate x squared plus 8x. I'm going to group the x's together. I'm going to leave some space, and then we're going to group the y's together. And then I like to group them up and leave some space here first. But I like to put the constant on the other side, okay? The way I was taught didn't do it this way. They did a lot of bookkeeping, and I did not like that. So what we're going to try to do is we're trying to figure out, like, what's the magic number I'm going to need to make x squared plus 8 plus something into a perfect square. What I would like to see is x plus something squared, okay? Or y plus something squared, okay? Plus or minus, okay? I don't really care which, but that's what I want this to factor to. So if I'm looking at this, I'm kind of seeing this like, well, that's plus 16. Right now, you should be asking me, like, wait a minute, how did you get that 16? Okay, so the way we got this was I'm going to identify the middle term. Okay, pretend that 16 isn't there just yet. If you were going to look at this like quadratic formula, it would be ax squared plus bx plus c. So that middle term, that b, that's equal to 8. Okay, now we're going to cut that in half. 4. Okay, and then we're going to go ahead and square it. So 4 squared is 16. That's the magic number that we need. Okay, now this is a really powerful technique, and I'll show you why when we do this. Okay, I'm going to use b for this one as well. You want to put a little x here, so it's the b that goes with the x one. That's fine. We could put a little y there to say this is the b that specifically goes with this one, and that's 4. So b over 2, right? That's half of 4 is 2. And this point, you're probably saying, why did you go through all this to get 4? Like, well, because we got 4. Okay. Now, I can't just go around adding 16 and adding 4 to everybody, right? That's not going to balance my equation. So what I need to do is on the other side of the equation, I need to add this so that they match. Okay. So here I get 16. We put 16 on the other side. If we got a 4, we're going to put a 4 on the other side. All right. So now we can factor this, right? This is just going to be b, or it's going to not be too much b's. We're just going to have x plus 4, right? Because we can factor this. Plus y plus 2. And then we got to add up the right-hand side here, right? 16 and 4 would be 20, and then 25. Well, they really like 25, don't they? So this is now my circle. We've now put the circle into standard form. If I want to get the center, right, that's going to be x minus a negative 4 squared plus y minus a negative 2 squared, because we have to break that positive. So my center, right, that's negative 4, negative 2. My radius, right, that's r squared is equal to 25, right? R squared is equal to 25. Let me get rid of it. Don't write it there. So the radius by itself is just 5. Okay? So that's how that works. Notice that here I had a 4, and then surprisingly, this was 4. And the same thing, b over 2 here gave me a 2. And notice that we also have a 2 down here. That's always going to work. Okay, I can give you some kind of crazy thing to complete the square on. And if you follow this method, you're going to know how to factor it because you went through this method and it lays it out for you. You're going to know what to add. You're going to know what it factors to. So no matter how crazy this gets, it's going to be able to work. Now, there is one little condition on doing complete the square, and that's that this number in front of the x and this number in front of the y, that has to be a 1, okay? I mean, it doesn't have to be, but there's another step involved if it isn't, all right? We force the issue on that. But I don't think anything in this part of your book has these as anything but ones, unless like you could divide everything by 2, or maybe it's a 2 and everything is divisible by 2. So they might do that to you, but just make sure that this is both a 1 in each case, all right? But if it's not that, they're both going to be the same number in front, okay? And you can just divide.
Mark,
Yes.
so the book has us, you did the b/2 and the book just does it by 1/2. Is that pretty much the same thing?
That is exactly the same thing. So if I have half of $1, right? Or that I have $1, if I have half $1 or, actually I just said it. We have 1/2 times $1 or half $1. It's the same thing. So 1/2 times a number is the same as that number over 2. That's an excellent question. Thank you.
Thank you.
Because that's how we do that, and they're both going to be 5. So beautiful. Thank you for that. Okay. So yeah, that's how that goes. So let's go ahead and now we can answer the question, right? We can say, oh, I know what this is now. Okay, so in standard form, right? We're going to have what this was x plus 4, right? We have y plus 2, I thought. Oops, I want plus 2. No. Back up here. There we go. And it's equal to, don't forget to square the, right? It's 25. It's got to be r squared up here. Right? And I got the right one. Yep. Now, we have a circle. Sometimes they lie to us. Okay, your book will do this. It will lie to you. It will tell you, oh, graph the circle. If you end up, so on this other side here, right, if we just go with the same thing, x plus 4 squared plus y plus 2 squared, if we end up with a 0 on this side, it's what they call the degenerate case. Right, so if the right-hand side is 0, it's a degenerate case. Because it's just a point, okay? If it's negative, then it's like an inside-out circle, but we don't do that. We just say it doesn't exist. Okay, we don't put negatives on the other side and assume that they're squares of something, okay? So if you get a 0 on the right-hand side, it could happen. It's a degenerate case. Or if you get a negative, that's worse. That's inside out, that doesn't exist, okay? So when you come back over here and you say, well, is it a circle or not? Well, the right-hand side wasn't 0 and it was positive, so we have a circle. All right, hooray, they're happy. Okay, they want the center too? Fine, here's a -4 and a -2. And then my radius was a 5. I go back to looking at this thing again. All right. So let me see if I can do this. Are they going to give us an easier one or a harder one over here? Hold on for a second. I'm just going to go check to see how many, which one of these they give us, and if they do something terrible, then I'll know. Oh, they are kind to you. All right. I'll be kind too. I know we changed how this class works a little bit ago, so I'm still adjusting to how fast I should throw the balls at you. Okay, so this one, we have x squared Just so you know, the way we used to do this class, this occurred about this time of the semester, but I would do terrible things to my students. I would make them do things like this. So it doesn't change it by much, but instead of a 6, I make it a 5. And then if you went through and tried to do this, you'll see, like when you try to do b is equal to 5, and then b divided by 2 is 5 halves, and then you have to add, you know, this thing squared of 25/4 to both sides. So that's what I used to do. Like I said, we changed books a little bit. Like last year, and we changed what the requirements were a little bit. So I won't do this to you. If the book does, then I will. But generally, if you don't see one like this, I'm not doing this to you. So here we go. Let's group them. X squared minus 16x plus y squared plus 6y. And even though it's going to be a negative, I still want to move it off to the other side. I just don't like having the constant mess around with this stuff here. All right. So my middle term here, right, negative 16, and bx divided by 2, or half, is negative 8. And then we have to square it. And again, remember that you are smarter than your calculator, and you should be getting a 64. Okay, positive. Same thing over here, right? We have our by is equal to 6. Our by over 2 is equal to 3, half of it, right? Half of 6. And then we're going to square it. And that is equal to 9. So the magic numbers I have to add to the left-hand side, I've got to add them to the right-hand side. So we're going to have, oh, you know what I'll do? I'll do it this way. Okay, so we'll do a plus 64 and a plus 9, but I got to do it on both sides. So we're going to have a plus 9 and a plus 64. Okay, you know this came out of a textbook because we got lucky here, all right? So we're going to be doing fine with that. All right, so we can factor this. And if you're like, I don't really know, it's late, I haven't had enough coffee yet today, I know that this is x minus 8 squared, and that's going to give me my 64 plus, and this is going to be y minus 3 squared, and that's going to give me my 9. And I know it's, I didn't look at it, I know it's the 3 because I know that that's going to work that way. But if you go back and factor it properly, you still end up with a 3. And that's equal to 64. Okay. Let's see what we got. Y plus 3, let me check. Ah, thank you. Yes, plus, thank you. Yeah, I lose my signs too, which is why I like teaching in person, because you guys are really good about catching me. So that's good. So thank you for that. Okay, so fantastic. All right, now that's our circle, right? So where's our center? Right, center is at 8, negative 3, because remember this is y minus a negative 3, right? And my radius squared, r squared is equal to 64. We got to take the square root of that. Radius is equal to 8 again. Okay, so let's go ahead and write our equation in standard form. So we have, right, it was x minus 8 squared. Always double check in here, because, and then plus. Again, if you get stuck up in the exponent, hit the arrow key to go over one, to go to the right one more, and it'll knock you out of that. All right, and since we have a right, we have on the other side, we don't. This isn't 0. It's negative. It's positive. It's fine. So we're sitting here as that. It's a regular circle. We'll check. All right, and then we're going to figure out the center. They're not going to make us graph it. That's too bad. All right, negative 3. Right, 8, negative 3, and our radius was 8, just how we talked, just how we did it back down here. All right, and let's go ahead and check that. And then, hooray, they're happy with us. Okay, let me just double check 15 to see if they're, yeah, we're good. This is probably going to be not a nice case though. Okay, so I'll either stop there because it's been about an hour and I'll let you guys end up with the thing. So here's what we're going to do is I'm going to stop recording. If you guys have another question or so, that please ask them. I know some people are shy about, this is going to appear on YouTube. So, although I seriously doubt anybody's going to wait through 50 minutes to find your name, but you never know. Okay, so let's go ahead and stop recording and then